Hello friends, welcome back to my YouTube channel. From this lecture, I will start the lecture series on leaching. So this is part number 1 of the lecture series, and in this I will introduce leaching to you. So I will tell you what is leaching, and I will let you know about some other names for leaching, and at the end I will discuss few important applications of leaching. So let us start the discussion. Okay, to begin with, let us get an answer to this question. What is the question? What is leaching? So leaching, it is one of the oldest unit operations in chemical engineering. It is one of the oldest unit operations that is used in chemical industries. This unit operation, the unit operation of leaching, it is used to separate one or more components from a solid mixture. And in this case, the solid mixture is a homogeneous solid mixture. Because if it is a heterogeneous solid mixture, simple mechanical separation can be used. Simple mechanical operation can be used to separate the components if the solid mixture is heterogeneous. But we are talking about homogeneous solid mixture, and in order to separate one or more components from this homogeneous solid mixture, we use the unit operation of leaching. So the unit operation of leaching, it is used to separate one or more components from a homogeneous solid mixture. So for this, the homogeneous solid mixture is contacted with a suitable liquid, and this liquid is called the solvent. So the homogeneous solid mixture is contacted with a suitable liquid, that is the solvent, and during this contact, what happens? One or more components from the solid mixture, they get preferentially dissolved into the solvent, and it results in the formation of solution. How solution is formed? The solution is formed when the solvent preferentially dissolves one or more components from the solid mixture, from the homogeneous solid mixture into it. And once you get the solution, you need to separate components from this solution, and for that, the components from the resulting liquid solution, this solution, they are recovered by using some other mass transfer operation. And mostly, the other mass transfer operation that is used to separate components of this solution, the mass transfer operation most commonly used is distillation. Now let us understand this. For example, let us consider a homogeneous mixture of two solids A and B. Now, if this homogeneous solid mixture is contacted with a solvent in which B dissolves preferentially, so what is going to happen during the contact? There will be it will result in solution of B in the solvent, and then you can recover B from the solution by using some other mass transfer operation, which in most of the cases is distillation. So you can understand this with the help of this schematic diagram. Let us say that this is the solid mixture containing two components A and B, and it is contacted with a solvent which can preferentially dissolve B in it. A is not soluble in the solvent, so B will be getting transferred from the solid mixture to the solvent, and you will have solution of B in the solvent. And then you can separate B from the solution by using other mass transfer operation, which in most of the cases is distillation. So I hope you have understood what is leaching. Leaching is one of the oldest unit operations that is used in chemical industries. It is used to separate one or more components from a homogeneous solid mixture. For this, the homogeneous solid mixture, it is contacted with a suitable liquid. We call that liquid as the solvent. So at the end, we have solution of those separated components. And in order to separate those components from the solution, we need to use some other mass transfer operation. And in most of the cases, this mass transfer operation is distillation. And I have discussed one example to tell you how separation is done in leaching. So leaching, it involves contact of a solid phase with a liquid phase. Now let us understand how leaching is carried out in industries. So we will understand industrial leaching operation. So in an industrial leaching operation, what is done? The solid mixture, the homogeneous solid mixture, it is feed to the operation. So in industrial leaching operation, the feed is a homogeneous solid mixture from which one or more components are to be separated, from which one or more components are to be recovered. The feed mixture, it is contacted with the solvent. And what is the purpose of this contact? The purpose is to preferentially dissolve one or more components into it, one or more components into the solvent. The resulting solution, it is removed. So the solution of the separated components that is formed in the solvent, that solution is it is removed from the operation, and you call that solution as the clear solution or the overflow. Whereas the leftover solid mixture from which you have separated the solution, the leftover solid mixture, it is removed as the underflow or leached solids. Underflow or leached solids. So you need to understand one more thing in this case. Since you are separating clear solution from the solid mixture, you have to separate clear solution from the leftover solid mixture. Perfect separation is not possible. That means it is not possible to remove all the solution from the solid mixture. Some of the solution will be remaining with the solid mixture. And that is important to remember. The removed leach solids, that is in the underflow, there will also be some clear solution. So I am saying the removed leach solids will also contain some clear solution in there. So if you have to represent the operation schematically, you can represent it in this way. Let us say that this rectangular block is representing the leaching operation. So feed is a homogeneous solid mixture. So homogeneous solid mixture is admitted into the operation, and then it is contacted with a suitable liquid. We call that liquid as solvent. So solvent will be coming in contact with the solid mixture, and during this contact, one or more components from the solid mixture, they will be getting preferentially dissolved into the solvent. So you'll be getting a solution of those components in the solvent, and we will be removing that solution as overflow or clear solution. Clear solution or overflow. This is solution of separated components in the solvent. Solution of separated components. Separated components in the solvent. And as I said earlier, these components then have to be separated from the solution by using other mass transfer operation. Then the leftover solids, since perfect separation of the clear solution or overflow is not possible, some of the clear solution will remain with the leach solid. And then this mixture of leach solids and whatever clear solution is present with those leach solids, this mixture is removed and we remove that as underflow, or you say leach solids. So the underflow or leach solids, these are the solids from which most of the component are separated. Plus, it contains some clear solution with it. Why clear solution comes along with the underflow or comes along with the leach solids? The reason is it is not possible to have perfect separation of the clear solution from the leach solids. So, some of the clear solution is going to remain with the leached solids. So, in this way, you can simply understand the unit operation of leaching. So, feed is a homogeneous solid mixture. It is contacted with solvent. At the end, you will get solution of component separated, and that solution is overflow or clear solution. And then you have leftover solids, and this leftover solids will also contain some amount of clear solutions with them, and the leach solids along with the associated clear solution, those are removed from the operation as underflow, or you can call that as leached solids. So I hope you have understood the concept. You have understood how the operation of leaching is carried out. Now let us know few other names for leaching. So leaching is known by different names. So just for the sake of information, I am discussing this. So leaching, it is known by different names. You can call it as liquid solid leaching, since it is used to separate solute or solutes from a homogeneous solid mixture using liquid solvent. So it is also called liquid solid leaching. It was earlier called as percolation of liquid through a fixed bed of solid. So this is the original name of leaching. Percolation of liquid through a fixed bed of solid. Then you have lixiviation. What is lixiviation? It is leaching of alkali from wood ashes. A particular name is given to this operation. What is the operation? The operation is leaching of alkali from wood ashes. And what is the name? The name is lixiviation. Then you have another name, which is decoction. What is this? The leaching operation, when you use the solvent at its boiling point, that leaching operation is called decoction. So decoction is the name given to leaching operation when the solvent used is at its boiling point. Then elutriation or elution. So this is in this case when the solute or the material or the substance that is to be recovered, the component that is to be recovered, that is solute. So if this solute is largely present on the surface of the solid mixture, then this solute is just washed away by the solvent. So when you have a solid on the surface of which you have the component or the material that is to be recovered by or separated by leaching, and when you contract this solid with the solvent, so there will be simply washing away of this solute that is present on the surface. So the solute in this case is just washed away by the solvent, and this operation is called elutriation or elution. And if the solvent used is water, then elutriation or elution, it is simply called washing. So elutriation or elution is the leaching operation that is used to wash the solute that is present on the surface of the feed solid mixture. It is also called elution. And if you are using water as solvent, then this is simply called washing. So these are few other names for leaching. So you have liquid solid leaching, because it involves contact of liquid and solid phases. It is the original name of leaching was percolation of liquid through a fixed bed of solids. Then for the leaching of alkali from wood ashes, the operation is called lixiviation. And if in the leaching operation you are using solvent at its boiling point, then that operation is called decoction. And if the solute is largely present on the surface of the liquid, which will be simply washed away by the solvent, and then that operation is called elutriation or elution. And if you are using water as the solvent in that operation, then it is simply called washing. Okay, now let us know few applications of leaching. First, we will know the applications in metallurgical industries. So these industries are the industries which mostly use leaching. The most or large scale application of leaching is in metallurgical industries. So let us understand. It is mostly used for separating minerals from their ores. So the use of leaching in metallurgical industries is to separate minerals from their ores. So mineral ore, what is this? This is a solid mixture in which the mineral is present in small proportions along with other undesirable constituents. So in mineral ore, you have, if you have to represent, if this is a mineral ore, then the mineral is to be separated, and we are going to do that by using leaching, but it is surrounded by other undesirable constituents. So the mineral, that is the desirable material that is to be separated, it is present along with other undesirable constituents, and we have to separate this mineral from this mineral ore, and for that leaching is used. So let us understand it further. Now some of the examples for this, you have, say, copper minerals. They are separated from some of their ores by leaching with sulfuric acid or ammoniacal solutions. So copper minerals, for separating copper minerals from some of their ores, leaching is used. And in those leaching operations, the solvents that can be used are sulfuric acid or ammoniacal solutions. So this is one of the example. Then the other example is gold is separated from its ore by leaching with sodium cyanide solutions. So for separating gold from its ore, we use leaching, and the solvent used in that leaching operation is sodium cyanide solution. Then other industries which have appreciable applications for leaching, that industries are food processing industries. So many naturally occurring substances are separated from their original mixtures by leaching. So many naturally occurring substances that are present in plants or animal parts, so they are separated from their original mixture by leaching. Now some of the examples for this, you have leaching of sugar from sugar beets using hot water as solvent. So leaching of sugar from sugar beets, it is done by using hot water as the solvent. Then another example is leaching of vegetable oil from various oilseeds. So that is also okay. Continuing with food processing industries, some of the examples. One is leaching of leaching of sugar from sugar beets. The other application is leaching of vegetable oil from various oil seeds. Which are this oil seeds? You have soybeans, cotton seeds, sunflower seeds, etc. So vegetable oils from this oil seeds, it is recovered by using leaching. And the solvents used in this case, you have a variety of solvents, or you have solvents like benzene, acetone, ethers, etc. Then another example is leaching of tannin from various tea barks and by using water as the solvent. So tannin is leached out from various tree barks, and the solvent used in this case is water. Then another example is leaching of oil from the liver of halibut fish by using ether as the solvent. So the oil is recovered from liver of one kind of fish, halibut fish, and the recovery is done by using leaching. And in this leaching operation, the solvent used is ether. The preparation of tea and coffee, our household example. The preparation of tea and coffee is a leaching operation. And what is the solvent used in this case? The solvent used is hot water. So preparation of tea and coffee is an example of, you can say it is a household example of leaching. The leaching operation that is carried out in every house of our country. The preparation of tea and coffee, it is a leaching operation where the solvent used is water. And few other applications, many pharmaceutical products, they are separated from various plant parts like roots, leaves, stem, and it is done by leaching. Then leaching or washing of mother liquor from chemical precipitates. So for example, leaching of sodium hydroxide from the slurry of calcium carbonate and sodium hydroxide, which is formed in the chemical reaction between Na2CO3 and CaOH twice. A chemical reaction between Na2CO3 and CaOH twice, it produces calcium carbonate and sodium hydroxide. Calcium carbonate is the precipitate that is formed in the chemical reaction, whereas sodium hydroxide, this solution remains attached to this chemical precipitate. And then from this slurry, so you have slurry of calcium carbonate and sodium hydroxide, and from this slurry you can separate sodium hydroxide by using leaching. Okay, so with this I end my short discussion on introduction to leaching. So in this I have told you what is leaching, how it is carried out, what are the other names for leaching, and what are important applications of leaching. So with this I end my discussion for this video. Thanks for watching the video. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. In my in coming few videos, I will be discussing various important aspects of the unit operation of leaching. I am sure you will be with me in those video lectures. For now, thank you. Have a nice day. Bye bye.